What's up, crypto fans? Today we are introducing another AI build to you. It is very robust. You can see the price of Ether, which represents by this orange line, went up and down and eventually crashed to its low. Our AI performs really well on that period. It was constantly making money. Let's check these rebounds. Our AI was still able to catch it. The only downside about this AI is that it doesn't perform well during a flat period. I bet this majority of trading strategy out there, whether they are based on simple math or simple indicators or advanced technology like machine learning or deep learning, they usually do not perform very well when there isn't any market movements. If you want to see how accurate that this AI trades on data that it has already seen before, it is very simple. You just need to show the results from the training period rather than the testing period. Okay, now let's scroll down and check. I believe this AI has almost grasped all the necessary patterns it could possibly grasp from the training dataset, and it has been performed really well on following the market trend and periodicity. I will give a comment that this AI has done a really decent job on learning the historical dataset. Now let's switch back to testing the period again, because we will never judge an AI solely based on the training performance. We'll have to pay more closer look on the testing period, because testing period is the period that this AI will encounter data that it has never seen before, which can be reflected to live trading condition. Now we have learned how this AI perform on testing period. We know it is very good and robust. How does this AI get built up? Right, this is a more important question, because now we are getting into the architecture of this AI. Okay, let me show you guys right now. Alright, here is the architecture of our deep learning AI. It's very creative design, because we are not throwing everything into one LSTM layer like what I did with another deep learning AI program with Google TensorFlow AI library. For this architecture, we do it a versatile way. We throw price changes data, both absolute changes and changes in percentage, into a recurrent neural network layer, or simply known as RNN. And for our features, when we said features, we actually mean for those technical indicators like MACD, RSI, and moving average. Okay, we throw these indicators or features into a linear layer. It doesn't matter how many features or indicators you want to throw it in. It doesn't mean more is better, but having very limited features is not a good idea either. So you will have to test them on your own. And of course, you will need to find the best parameters for those indicators as well. We are not going to talk how these indicators get calculated. You just have to search them on Google, you will find out. For the reason why we didn't use RNN for features was because often technical indicators can reflect the weight of how the historical prices change, and for the results calculated by those technical indicators can be reflecting or categorizing the dynamics of price movements in the past. So it is the reason that we don't treat them in the same way. Okay, and after that, we make RNN hidden state concatenated with the results of the features or indicators linear layer. Then we put a decision linear layer with 10 activation function. The result of this neural network should be the number of shares to buy in the next step. But one more thing I need to mention is that the number of shares should be normalized and be in range of -1 and 1. If you haven't heard about 10 function, it is continuous function that gives any value between -1 and 1. In real life trading, we cannot buy stocks in any portion. I know for crypto is different, but for stocks we need to round them into the nearest integer. However, rounding function has derivative equal to 0 everywhere, so rounding function cannot be used in the gradient descent algorithm, which is the algorithm we use to improve our AI training. So for training, we assume it is allowed to buy shares in any pieces, but for our evaluation process, we can use rounding. Okay, this is our model architecture. Now I'm about to show the code for this project. For people who would like to see how this AI gets built, please stay till the end of this video. Before sharing the material, I would like to have you guys read our disclaimer again. All material provided on fastbook.com are for educational use only. If you decide decided to use this material for live trading, you will be responsible for your own risks. Okay, and for credit and source, we want to give credit to Ivan Gerding and Harvin Kaur for their book and code repository. The book is called Time Series Forecasting Using Deep Learning. It is really great book. I learned a lot from this book that Ivan wrote. He has explained things explicitly. He is definitely a qualified AI scientist. You can buy his book from Amazon. Alright, let's continue. Before beginning to code out this AI, you need to import all these essential libraries or modules. We will use PyTorch this time instead of TensorFlow. What is the difference between PyTorch and TensorFlow? To me, I just feel like TensorFlow is very easy and simple to use, but for PyTorch, it's more versatile, but it will be slightly more difficult to be good at it. Since I will be using Ethereum price data, so I need to pip install Python Binance and import a client from this library I line to 25. You will also need to install a library to calculate all the common technical indicators from library I line A. It is called pandas.ta. Okay, after all modules got imported successfully, you can now download the historical data from Binance API with your API key and API secret code. Both of them can be achieved under your user menu for free once you have registered your Binance account. Time interval is hourly. After you download the data, I have removed all the unnecessary columns from the pre-processing part and make sure all the values are float type at line 30. You can now save the clean data into your local directory if you want. This is the code to read the CSV from your local directory and show some basic information about your data. You can see the first hourly data was from January 1st in 2018. The last hourly data ends on May 18th in 2023. I have generated a graph to show all the historical data, and it looks like this. To get a bit more understanding from the historical data, you can show absolute changes. You just use the current price to subtract the previous price. I've also tried to show other few statistics just to get an idea about the stationarity of this time series. You can see the test statistics is minus 27 point something, which is smaller than any of the critical values. P-value is 0. What that means is to reject the null hypothesis, and which means this time series is in fact stationary. Why do we need to feed stationary data to the model? Because our AI model often does better after learning stationary data because there wasn't any stationality and trend involved, and our model will be able to grasp more patterns and will not be misled by stationality and trend from our time series. Let's do the same thing for relative change. Adafruit also shows that our relative changes time series is also stationary, so both time series are okay to be fed into the model later. Now let's build some functions. The first function we need to build is the function to slide your window. You will need that to slide your time series for price changes and also your time series for features. The second function we gotta build is the function to calculate technical indicators as our features. Some common indicators are listed out right there. Certainly there are more, but feel free to read more about their documents. Okay, finally we get to talk about the meat. This is the actual AI model. We simply name it RNN. Some necessary parameters we need to pass to this model are such as the input size for the RNN layer and the size of your features input. Of course, the RNN type, you can change it to GRU if you want. This is called gate recurrent units, very similar to RNN. To know more about the differences between GRU and RNN, please go read that by yourself, because there are quite many things going on in a single RNN cell or a GRU cell, and that will be too consuming to get that fully explained in this short video. Anyway, we'll be using RNN for price changes. Let's continue. You need to adjust the size for RNN hidden slide and the size for the linear layer for our features, and you will also need to adjust the size of the decision layer. And then you see we use the linear function from line 28 to line 30, which was imported from torch.nn in order to apply a linear transformation to all these sizes. nn.linear takes two parameters, the size or dimensionality of the input to the linear layer and the desired size or dimensionality of the output from the linear layer. It determines the number of neurons or units in the linear layer layer. What it does is basically matrix multiplication and bias addition. The input tensor is multiplied by a weight matrix. This matrix is initiated randomly and will be kept learning during the training process. After matrix multiplication, a bias term of size of the desired output is added element-wise to the result. The bias values are also initiated randomly like the weight matrix and will also be kept learning during the training process. After that, you can see a forward function has been added. This is oftenly called forward method, and this is something you must do when you decide to make an AI with PyTorch. If you only use TensorFlow, you wouldn't have seen this before. What it does is to define the forward path of the neural network. It specifies how the input is processed and passed through all the layers you created in order to generate the output. The order is exactly how the model architecture diagram has shown. Moving to the next, we got our training loss function. What is training loss function? It measures how a deep learning module feeds the training data set. You can call it the error of the model. However, for PyTorch, we do not have a built-in function to calculate this formula. That's why we need to code it out by ourselves. There is one more thing I need to say about this loss function. You know, deep learning model training process aims to minimize the loss function, but for our case, we use the mean return as a quality score of our model. For returns, the higher the better. That is why for our case, we want to maximize a loss function instead of minimizing it. Therefore, we use a negative value for our loss function. Okay, finally, we are ready to define our training function. From line 3 to line 4, you simply adjust the period you want for training and the slicing window, which we have defined already. For epochs, we set it to 500. What is one epoch, by the way? One epoch meaning an entire dataset is passed forward and backward through the neural network only once. There is definitely one of the key hyperparameters you need to fine-tune in order to improve the accuracy of your deep learning model. And we also have a training validation ratio. Usually we have 80% our training data for training and 20% for validating. From line 10 to line 18, we basically pass through all the hyperparameters, which we will define later under a dictionary. We will talk about that soon. And after passing through all the hyperparameters from line 20 to line 58, we need to slide our data set based on the training period and calculate our features or technical indicators and keep them under a other dictionary called data source. We then need to cut those data to the start day as well. Then we will slide these data based on the slicing window which we have said earlier. After that, you will finally get to do your training and validating data set, split and prepare them as tensor. Tensors in PyTorch are like NumPy array. This is something you must do for using PyTorch. Okay, from line 60 to line 103 are actually where the training takes place. I don't want to talk too much about it. I believe you can also do it the same after observing the code I have provided. But just one thing I need to give more clarification, which is at line 73, that Adam is an optimizer. It is known as adaptive moment estimation. What it does is calculate adaptive learning rate for each parameters. It also saves an exponentially decaying average of previous gradients. This is something you can do to improve your model, and at line 100 you will save the model you trained into your local directory. Okay, and here is the code to initiate your training. I think we don't need to talk too much about what is a seed, right? I think many people already know the seed for random. For PyTorch, you can also set up a seed. What that does is to enable reproducibility, so for your results can be reducible. From line 9 to line 28 are the parameters for the trainings, and we start our training at line 30. For the evaluation process, the parameters are the same as the parameters we wrote earlier for the training. For the period, you just need to make sure that not to use your training period, because for those data your model has already seen. You want to use the period your model has not seen before. These codes are almost the same as the code we wrote before for the function for training. You don't need to calculate your features and cut them to the start date and drop those NA rows. Then you create your X test and Y test only. You don't need to create X chain and Y chain for testing. Then you turn them into PyTorch tensor and grab some variables which will be used later. Now you can use your model parameters to run your prediction by loading your existing model from your local directory. Okay, eventually we use the torch.noGrad method to generate our test results, which are the cumulative sum of the absolute returns of our trading done by the deep learning model and price differences of either. So we can plot the graph out with Matplotlib. And that's everything we need to cover for this full course of how to build a deep learning AI to trade Ether. If you like it, please try that for stocks or any other assets you like. You can fine-tune the model yourself or calculate your preferred indicators and use it for training. Please let me know how you did with your own testing from the comment below. I will greatly appreciate that. Okay, that's everything for the day. Thank you guys for watching. I will see you on the next one.